Welcome to Tech Lab by Sid. What is cache? Cache refers to a small, high-speed storage system or memory component used to temporarily store frequently accessed data or instructions. Its purpose is to reduce the time it takes for a processor or system to retrieve data from a slower, larger storage medium, such as RAM, hard drives, or databases. By keeping copies of frequently used data close to the CPU or other processing units, caches significantly improve the performance of computer systems. Types of cache. CPU cache. Located inside or close to the CPU caches store copies of frequently accessed instructions or data to speed up processing. There are typically multiple levels of CPU cache. L1 cache are smallest and fastest, located directly on the CPU core. L2 cache are larger than L1 but still faster than main memory, may be located on the CPU or nearby. L3 cache are larger and slower than L1 and L2 but still faster than main memory, often shared among multiple CPU cores. Disk cache. Used by hard drives, HDDs, or solid-state drives, SSDs, to temporarily store data that is frequently accessed. Disk cache helps reduce the time required to retrieve data from slower storage devices. Web cache. In web browsers or web servers, a cache stores copies of previously visited web pages, images, and other resources. This reduces the need to fetch the same data from the internet every time, speeding up loading times for users. Application cache. Software programs often use cache to store data that doesn't change frequently, such as configuration settings or user preferences, so that it can be quickly accessed when needed. Cache mechanism. Data request. When the system needs to retrieve data, it first checks if the data is available in the cache. This is called a cache hit. Cache miss. If the data isn't in the cache, it must be fetched from the slower, larger memory or storage called a cache miss. Replacement policy. Caches have strategies for replacing data when new data needs to be stored. Common strategies include least recently used, or LRU, replaces the data that hasn't been used for the longest time. First in, first out, or FIFO, replaces the oldest data. Random replacement replaces data randomly. Benefits of caching. Speed. Since cache memory is much faster than main memory or hard drives, caching speeds up data retrieval. Efficiency. Reduces the load on slower storage systems, improving overall system performance. Reduced latency. By storing frequently used data closer to where it's needed, caches minimize delays in data access. Examples of caching in action. When you visit a website, your browser stores parts of that page, like images, HTML files, etc., in its cache. The next time you visit the same site, the browser can load some elements directly from the cache, speeding up the process. In databases, query results that are often requested can be cached to speed up responses for recurring queries. Cache consistency. Maintaining consistency between the cache and the underlying data is an important challenge. If data in the cache is updated but not reflected in the main memory, or vice versa, it can lead to incorrect or outdated information being used. Different cache invalidation strategies are used to ensure data accuracy. In summary, a cache is a high-speed memory layer designed to speed up data access by storing frequently used information temporarily, which reduces the time required to fetch data from slower storage. Thanks for watching the video.